Let's go to new problems. All right, so we're on then to 8.4, the big and the bad, 8.4. So what I'm going to do in this section, we are going to get 3 log properties. Hey, look in the back. Does anybody recognize that guy in the back? Who is that guy? Thank you. I hope you all recognize him, or at least several of you, because he is here to help you, and he's over in the tutoring center to help you. Right? You all know about that. If you have any trouble at all, he's there to help. See how he checks in every now and then? He'll teach you the same way. All right. So, who is that masked man? All right. So, 3 log properties. I'm going to give you 3 rules for logs here. So, rule number 1. Wait, let me get the right color going here. Okay. So, log base b of x times y is log base b of x plus log base b of y. Log base b of x divided by y is log base b of x minus log base b of y. And log base b of x to the power p comes down to the front like that.
Greek.
All right, try that. Can you read it? So it's log base 6 of 16 times 19. Try that one. So use the properties. Which property is that going to use? 1, 2, or 3?
1.
Property number 1 because it's multiplied, huh? So 1 log, and log base 6, the 6 isn't going anywhere, right? 1 log with multiplication, harder operation, becomes 2 log base 6s with adding, like that. And then pop in the 16 and the 19.
How would you plug it in?
Just type it in just like that?
Do they have like a log button? I can't find it.
No, they don't have a log button. Just type LOG.
Oh.
Yeah, just type LOG, and then you got to go subscript. You got to go down for the 6 on that. Yeah, why don't we type one of those? Okay, so log base b of hx. Use properties. That's what I'm going to say the whole hour. Use the properties. Use the properties. So which property is that one? Well, what's in the middle of that h and that x?
Multiply.
Nothing, which means times, huh? There's no symbol in between. It means multiply. That's property number 1 yet again, because that's the multiply.
It tells you like the expression.
Oh, it even tells you. Yeah, I won't be so nice on the exam.
No.
I might. I don't know.
You're gonna keep us guessing.
That's right. Do something. So, 1 log with multiplication, a harder operation, becomes 2 logs with an easier operation, just adding. Right? That's a simpler operation. One of them gets the h, one of them gets x. Make sure you remember it's real picky with uppercase, lowercase, so make sure you do that. And there we go. We used property number 1 yet again. Good. I'll move on. We okay? So log base c of 19 plus log base c of 36. So now we have 2 logs added. And see what they're saying? Express as a single log. So take those 2 logs and put them together as 1 log. So how do we take those 2 and put it together? We're basically going to take property number 1 and run it backwards, right? Make 2 into 1.
Kind of figure some workload. Put the log back together.
2 logs added. Easy job for 2 logs. Easy to lift that table for 2 logs. Becomes 1 log, harder operation multiplied. And then whatever that number is. I know I assume they probably want you to multiply those numbers. Whatever that is. 684? Does everybody see what I did there? Adding for 2 logs, easy operation for 2 people, becomes a harder operation. It's times for only 1 log. Everybody see that? We made it into 1 log. Questions on that? All right. Yeah, that's right. If there's numbers or something to actually work out, go ahead and do that. All right, log base C of K plus log base C of P. What do they want me to do? Combine them to a single log. So put them together into a single log. So adding, easy operation for 2 logs, becomes a harder job for only 1 log. It's going to become K times B, or just KP. It means multiply. If you don't have to put that symbol. You can just say log base C of KP. It means times, huh? When there's nothing in the middle. So that's good. Log base C of KP. You all good? KP. Do you want to go with some different letters, Ajay? All is good? All right. Log base P of Z to the 13th. Now, what are they wanting me to do? Which of the 3 properties has like a power thing in it? Property number 3, huh? So property number 3 is the only one that's just 1 log to 1 log. Notice. Properties 1 and 2 both go 1 log to 2 log, 1 log to 2 log, but property 3 is just 1 log, 1 log. So what do you do on this one? What does property 3 says that power does? At 13, drops down to the front. And we're done. That's all we need to do. That's what property 3 says. You can, when you got a power on 1 log, you can just drop it to the front, just make it times. Power became times. Good? Ajay? Z, you mean is it the exponent of the P? You know, it's a good question. What it is, notice how everything is on the level and P is below the level. So that's what it really is. Z is just normal on the level. It's just P is lowered down. P is the base.
It's the anti-exponent. It's like
Yeah, it's the base.
yeah.
The base is the lower down when everything else is on the level. Yeah. So it's not really the P's power, although it looks like it. Yeah, good question. So log, that 10, see that 10's lowered down a little bit? So that 10's the base, it's the lower down number, and we never mess with the base. That's just not going to change. Just leave log base 10 and log base 10. And then what happens on this one? Same thing, yeah, that power falls down to the front, becomes 12 log base 10 of P. Why do they say the words express as a product? What does that mean? Product is multiplication. I made it 12 times, huh? Power became product. Power became multiplication, didn't it? Everybody good there? So there we go. Powers drop down to the front. That's actually the most important property of the log right there is number 3, even though it's the simplest. So log base B, 45 over 14. So what do they want me to do on this one?
Oh, yeah.
Which one of our properties has a fraction? Property number 2. Yeah. So dividing for 1 log comes down a level and becomes simple subtraction for 2 logs, doesn't it? what property 2 says. Like that, we good? We're done. So notice how dividing goes with subtraction. They both make things smaller, right? Dividing things, subtracting things makes it smaller. Whereas multiplying and adding go together, they both make things bigger, don't they? Good? Seeming okay? All right. So there we go. Try that. And they're giving you multiple choice answers over there. Do the problem or just guess the answer. All right, so subtraction between 2 logs is easy operation for 2 logs, is a little bit harder for 1 log, dividing, right? Dividing is a higher level operation for 1 log. So it's answer C, isn't it? We good? Subtraction for 2 logs, easy operation for 2, easy job for 2 people, little harder job for 1 person, dividing for 1 log, higher level operation.
So the first one's always going to do the top.
Yeah, the order matters, right? Because the order of subtraction matters. Yeah, so the first one goes in the top. Exactly. So it's answer C. Yeah, good point. First one goes in the top. All right. So log base C, x to the 6th, y squared z. So they basically want me to break this thing all apart into different logarithms. So we have 3 letters. I'm actually going to now, the properties I gave you on the sideboard over there are for going to 2 logs, but it's the same thing if you go to 3. So instead of having 2 things multiplied, x and y, I have 3 things multiplied, x, y, and z. So I'm going to have 3 logs. And they're all going to have the same base. Remember, the base never changes. Log base c, log base c, log base c. That never changes. The base is permanently glued to the g there, to the log word. And then we're going to have an x and a y and a z. And yeah, where are the powers going to go? They're going to go to the front of their individual log. And these will be added logs. There we go. Everybody see that? See how there are 3 added logs? Like that. 3 added logs. Powers come to the front. And it's added because these guys are times. Times becomes adding. Divide becomes subtract. Questions? Easiest thing you've ever done in your life?
No.
No? Weirdest thing? All right, so we have, well, let me just let you do that one. Give it a go. Break it in, they want 3 logs. You're going to make that into 3 logs. You got X, Y, and Z. We'll break that into 3 logs. And they're all going to be log base B. The base isn't moving. So the x and the y squared on the top are multiplied. So they'll become added logs. The z on the bottom is divided, so it'll become a subtracted log, right? So it's going to be log base b of x plus, and then the 2 is going to go in front of the y log, 2 log base b of y minus, because the z is on the bottom, 9 log base b of z. Does that make sense? The stuff on the top that's multiplied becomes added. See how those two become added? Because x and y are timesed. Multiplying becomes adding, right? And then the z is on the bottom, so that's subtracted. Dividing is subtraction, right? And the powers go to the front. When you make one log into several logs, right? The operations get easier. It's an easier job for 3 people, just adding and subtracting. It's a harder job for 1 log. It's multiplying and dividing. Everybody see that? See how those properties are working? The weird and strange log properties. All good? Okay, so log base C, let me write it up here a little bigger. Log base C of the 5th root of x to the 3rd over y to the 5th z to the 6th. Okay. That 5th root, what's a 5th root? I mean, like if I just had like w or whatever to the 5th root, can we rewrite that as w to some power? Do you remember how that works? Good, 1/5, good memory. Yeah, remember, roots are fractional powers. Remember that? No. So if you have blah, 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 because I just want you to know it's anything, right, is a 5th root, then that's blah, blah, blah to the 1/5 power. Remember I did the Scooby-Doo story and everything, said about how many cartoons I watched when I was a kid, and I always think of Scooby-Dooby-Doo. He runs around here, you know, and falls in the trap door. Remember all that intro show where he runs and falls? Seen it too many times. So fractional power, denominator swings in the hook. It's the same thing. Really important. We're going to use that a ton. Got to know it like you know the back of your hand. Fractional powers are roots. Negative powers flip things. That's different. Fractional powers are roots. So you really want, let me write it out without a blah, blah, blah there. Let me make it an X or something. Yeah, you want to know those power rules really, really well. So power rules. So power rules. Number 1, anything to the fractional power is the bth root of x to the a, right? The b swings into the hook, doesn't it? The denominator of the power swings into the hook. Okay, so what? Well, that means this 5th root thing is a big 1/5 power, isn't it? We good to there? That's not a log property. I haven't done any log stuff yet. That's just what we already knew, I was hoping, about fractional powers and roots, as we have covered them before. And I thought you guys never forgot anything we talk about in here. Fractional powers are roots. Most of it's out. All right, we good to there now? It's all coming back? All right, so now what do we do with powers? Where's that 1/5 power? Now that we know, okay, hey, 5th root, you're really a 1/5 power. Everybody see why it's 1/5 and not 5? Because whatever's in the hook goes to the denominator. Remember, Scooby-Doo falls down through the trap door and ends up in the trap. That's my little memory anyway. Okay, so it's denominator. So anyway, what do? Well, it goes to the front. That's hard. Now we're doing log properties, right? Any power in the front goes to the front. Any power goes to the front, right? That's log property 3. So now I'll take that 1/5 to the front.
The whole 1/5, not just 5.
What's that?
The whole 1/5.
The whole 1/5 goes to the front like that. Good. To there. So the fifth root became a 1/5 power, and the 1/5 goes to the front. And now just do the rest like normal. You know what x cubed on the top means, right? It's going to be, and they're going to have a 1/5 with each of them. So this will become 3/5 log base c of x minus 5/5 log base c of y minus 6/5 log base c of z.
Could you just leave it as a 1?
Yeah, we'll make that a 1 in a second. Correct. So everybody see why that happened, though. So the powers, like the 3 power, comes to the front and becomes 3/5 for the log. So that's what the power, the third property says, powers come to the front. So first I brought the 1/5 to the front, and now I'm bringing the 3 to the front, the 5 to the front, right? This 3 went up here, the 5 went up there, and the 6 went up there. Everybody good with that? So that's just the rule that powers on logs go to the front, don't they? Powers on logs go to the front. So, last step, what is 5/5? That's a 1, like Abraham was saying. And there we go. Hey, I'm expecting, I would have, if I was you and looking at this, I would think, wait a minute, Miss Taryn. Why, I understand why you're doing the minus in the first one, because that's divide. The divide, right? Right, dividing becomes minus. But why are you putting minus in the second one? Shouldn't this one be plus, because these guys are timesing each other down here? Right? No property 2, or 1. Times is plus. Right? But it's actually in the denominator. So even though they're timesing, when you're in the denominator, you're really divided. It doesn't matter that there's a little times here. This means x cubed over y to the 5th, and it means x cubed over z to the 6th. That is dividing. When you're in a denominator, you're divided. You're for sure divided. So it's really both are minus because both are divided.
So it only matters when they're in the top.
Really, it does. Well said. Anything in the top is really going to be plus because it's multiplied. Anything in the bottom is really divided, is really minus. Do you know what I'm talking about? I'm talking about these properties, right? Talking about property number 1. What does it say? If you're times, you're plus. If you're divided, you're subtraction. Well, I'm telling you now, to fill out that rule more thoroughly, anything in a numerator is really times. Anything in a denominator is really subtracted. Because that's what it means to be in the denominator. You're divided, so the log property changes you to subtraction. So these y and the z, both being in the denominator, are both subtracted. Because that's being divided when you're in the denominator. How are we doing? We good? And all the powers just go to the front, don't they? So the 5th root became a 1/5 power, went to the front. Then the 3, the 5, and the 6 went to the front of each of them also. All right. All right, so try that one. Log base b, 4th root of, m to the 20th, n to the 8th, over b to the 3rd. So break it into several logs.
That's a tree. It needs to be put down in the box.
So what are you going to do with that 4th root? So 1/4 power, isn't it? All right, so the fourth root, again, the fourth root, I'll just change it right here, becomes a 1/4 power, doesn't it? Scooby-Doo and his fallen through the trap door. So in the root is in the denominator. So that fractional power thing, that comes to the front, doesn't it? So you get a 1/4 in the front. And you can do this all in one step if you prefer. I'll do it in a couple steps. Good so far? So a fourth root is a 1/4 power, as we talked about, and that comes to the front. And now, now the 20, the 8, and the 3 will come to the front for each of their separate logs. So 20 over 4 log base b of m plus 8 over 4 log base b of n minus 3 over 4 log base b of b. Good to there so far? Everybody see how I got that? I'm going to simplify those, but everybody see how I got to there? So the fourth root is a 1/4 power, comes to the front, and then the 20, the 8, and the 3 come to the front. Right? Here's the 20, the 8, and the 3. And the ones on the top are timesed, so it becomes plus. So the m and the n are on the top, so they're added. And the b is on the bottom, so he's subtracted. So everybody see why the b is subtracted? Being on the bottom. And the m and the n are added because they're on the top. We good? Now, there's a little bit more we can do here. What is 20 over 4? 5. And then 8 over 4 is 2. Good. Everybody good to there? Now, there's probably one, I'm assuming, that nobody knows logs yet this well. There's something special you can do when they match. See how those are the same? Right? The other ones, log b of m, they're different. B of n, whatever, nothing, no big deal. But when you have the base and the plug-in being exactly the same, there's something you can do. What do you know? Do you know?
Get rid of the base.
You know, but you're not thinking about it. We did it yesterday, Monday. Think about this. Remember how we learned, how do you do like log base, 3 of 7? On your calculator, I mean. Remember what you did in your calculator to get the number?
Log 7 over 1.
Yeah, exactly, right. The top one goes top, the bottom one goes bottom, and whatever your calculator says, right? Okay, stay with me for a second. So what if I did log 3 of 3? What if they were the same? It would be, again, the top one goes top, the bottom one goes bottom, and what is that?
1.
You see when they match? If this is B and B, then this is B and B. It's got to be 1, doesn't it? Based on what we learned Monday. So when you see this, this is 1. So this is just minus 3/4 times 1, and you don't need the 1. It's just minus 3/4. Done. So see when they match? When they match, it's a 1, isn't it? From what we learned on Monday. The top goes top, the bottom goes bottom. The same thing over itself. That's 1.
So the log goes away too?
Yeah. Right? Let's look back. Didn't the right? What would the log base 3 of 3 be? The top goes top, the bottom goes bottom. So what is that?
1.
It's not log of 1, is it? The whole thing cancels, right? That's 1, right? Same thing over itself. That good? We all happy? I'm aiming to please here. Is that good? What's that, Ajay? That's the answer. That is it. We are done. I know, we keep taking more steps, huh? That's the final answer. All right. You guys can do this stuff. All right. So we've got 3/4 log base c of x minus 1/2 log base c of y. Now, what do they want me to do this time? You got to kind of watch the words because they'll ask you for different things at different times. What do they want us to do here? Make it a single log. You know, so crunch them together. Make it into one log. Okay. I'll give you a second. See what you can do. I bet you can figure that one out. What are the 3/4 and the half, those numbers in the front, where are they going to go?
They're gonna go into the book of the, with the record.
Look at property number 3. Numbers in the front can go back to the power zone, huh? Just run that property backwards. You with me? Right, so just take that 3/4 and put him up there. Take that half and put him up there. Make sense? Right, so we have that, you know, you can, at any time you want, you can go from power to front or front back to power. That's what property 3 is saying. There's this transition you can do from front to power or power to front. Depending on what you're trying to do at the moment, you can go either way. Right, good. So what? Well, then that means log base C. I'm going to make it one log now. It's a subtraction. So what does that mean? It's going to be with the x and the y. Division, huh? And the x is going to have the 3/4 and the y is going to have the 1/2, and we're done. Is that good? See how that happened? The subtraction became dividing, and the numbers in the front went to the power. Now, if you're wondering, but I thought you said those are roots. Well, that's true, but they're not asking me to make roots.
Oh, okay.
I'm going to do only what they ask for. They said, make it one log, please. And I'm saying, there you go. It's one log.
Because they're gonna ask us to do radical.
At other times, we might have to do radical stuff, yeah. But on this one, all they said is, please make it one log, and I've done so. Like good? Getting the hang of those properties? So the subtracting became dividing, and the numbers in the front went to the power. All right, let's. All right, you want to try that one? Maybe I'll write it up here. So log base b of 3x plus 7 times log base b of x minus log base b of y. I would start, by the way, with just distributing that 7. Just get log base b of 3x plus 7 log base b of x, or minus 7 log base b of y. That good to there? So just distribute that 7. And then, what do they want you to do? Single log. So crunch them all together into one log. Okay, so what am I going to do with that 7 in the front? Right there, huh? What about this 7? Right there. Because I want to put it, yeah, good question. So I want to put them together, and so I need the stuff off the front of the logs to push them all together. And that's property 3, right? Property 3 says you can go from the front to the power, or vice versa, anytime you want. Everybody see this? Right? Property 3 says you can be power, go front, or front, back to power. That makes sense? How we're doing property 3? And anytime you want, you can go from front to power, or back. Now, why do I want to go this way? Well, because I have to get stuff out of the way of the front so I can put them all into one log. Okay, so now we've got 3x times x to the 7th over y to the 7th. Right? The first two logs are added, so that's numerator multiplied in the top. The y log is subtracted, so that's denominator. Remember, subtraction is denominator, adding is numerator. Adding is multiply, which means numerator. It says property number 1. And last step. What is 3x times x to the 7th? 3x to the 8th, huh? At 1 power and 7 power add over y to the 7th. How we doing? Am I just doing the problems and you're just kind of following along, or is this making sense? Anything I can answer? Does that make sense why I'm doing that? So run through it again, maybe. So the 7 I just distributed, nothing fancy there. Went in the front, and then I realized, okay, things in the front can go to the power, And then I just did the properties, adding, those two go in the top, subtracting, he goes in the bottom. And you know what 3x times x to the 7th is? 3x to the 8th, huh? Is that okay? You guys are giving kind of weird looks to the screen, so I just keep talking. It is a little weird. It is weird. So I'm doing those properties basically in little pieces here and there. All right. Some of the old square root rules and stuff, which you know all the rules for this. Just got to be real careful putting it all together. Okay. So, yeah, let me help with this one. It's got a little weird stuff. So, okay. So first thing I'm going to do, they want me to make it a single log. So make the 2 1 log. It says subtraction, doesn't it? So subtraction is division, right? That's property 2. Subtraction is division. And what's division really mean? Denominator, huh? Denominator. You with me? So think that way. That'll really help make things easier. Whenever you think of divide, just think, put it in the denominator. That is the place where division occurs, is the bottom of a fraction, right? So what I'm saying is, you'll take log base b, that's not changing, b over root x, let's just start with that one, that's the first one, and then minus this one, not the log b, that's, we've already got that. The root bx, it's minus the root bx. So where's the root bx going to go if it's minus? Root bx right there in the denominator. Does that make sense so far? Because that's what divided means. It means you put it in the denominator. That is dividing it when you put it in the denominator. I do that because what I've seen some people do over time is go like this over like that. And that's true, but that's kind of a pain to deal with. It's so big and ugly and everything. So yeah, that's true. That is also dividing. But it'll be way easier for you to just say, look, I'm just going to stick it right there inside the fraction we've already got. That'll be a lot easier for you. So remember, whenever you put something in a denominator, you have divided it. That is dividing. So far, so good. So it's in the denominator. So what happened was the subtraction became dividing. The one on the right goes on the bottom. Okay, now, can I clean that up at all? Just using normal rules of square roots and things. Let's try to do
You can factor the x out.
some of that. Yeah, look, see how we have 2 x's inside roots? What does 2 x's inside a root do?
1 x.
Sends 1 out, huh? It's 2 for 1 deal at target. 2 x's in, 1 x goes right there, and they're both gone. So we get log base b of b over x root b. Everybody good so far? See what happens? See how the two x's inside roots sent one x outside root on the bottom? It's all still staying on the bottom. Is that good to there so far?
It's not done.
Yeah, it's close. It's not done because remember what we can't ever leave in the denominator? Square root. Yeah, so how do we get rid of that root from the bottom there? Yeah.
Multiply by root b.
What's that? Like this?
You have to.
Really? Simplify your answer. Do not use fractional exponents. Really? Wow. Let me show you what else you could do. Yeah, because my question is which way do they do the multiple choice answers on the test? I don't remember. So this is okay, obviously. They took it. But you could also multiply top and bottom by root b, which someone might do on a test question. And so then you would get what? Log base b. On the top, you'd have b root b.
Yeah.
On the bottom, you'd have x. And what is root b on the bottom? Plain b.
So bx.
Good so far? Everybody see I multiplied top and bottom. Why? Because I'm trying to get rid of the root. I thought they never wanted roots in the bottom. So I'm multiplying top and bottom by root b. Top is b root b. The bottom is x. And then root b is plain b. And then these can cancel now, huh? There's no glue there. There's no Costco. We can cancel just the b's. That's fine. Nobody's glued together. No package deals required.
So root b over x.
So we get log base b of root b over x. I thought they would require us to go to that point because that's simplified, but they took it the other way. So either one on a multiple choice test would be right. That good?